Our speaker today is Associate Professor Vinay Setty from the Department of Electrical Engineering and Computer Science of the University of Stavanger, and he will summarize for us the latest research developments in the area of automated fact-checking. And Vinay is also a task leader in our work package 3 on media content analysis and production related to this theme. He got his PhD from the University of Oslo, and before moving to Stavanger, he was also an assistant professor at Aalborg University and a postdoctoral researcher at Max Planck Institute for Informatics. And his research areas include information retrieval and text and graph mining using machine learning techniques. He's got a long list of publications, and some of them in highly competitive conferences in the area of data mining and information retrieval. So with that, I leave the word to you, Vinay, and you are planning to talk for about 50 minutes, so we have some time left over at the end for questions and answers, and you may enter these questions and answers in the chat as we go along. I don't think it's possible for you to chat to one another because we've had some problem with spamming in an earlier session, but we as hosts will see your questions, so we and I will be able to address them at the end. Okay, so please, Vinay.
Thank you, Andreas. Hello, everyone. Today I want to talk about DeepFact, deep neural networks for automated fact-checking. As Andreas introduced, I'm an associate professor at the University of Stavanger. I'm also a co-founder and CTO at a startup called Factiverse. So let's get started. I was told to give a quick shout out to seminar series at the Media Futures. If you go to Media Futures website /seminar series, you can find upcoming seminars. Yeah. So let's start with what is fake news. It is a loaded term. I think it is very important to understand what we mean by fake news and what is the difference between fake news and fact-checking, for example. So the Cambridge Dictionary defines fake news as false stories that appear to be news, which are usually used to create influence on political views or as a joke, right? This is one way of defining fake news. But I think a better definition can be found in Wikipedia, which defines it as fabricated news, which can be used for propaganda, disinformation, or hoaxes. And then it goes on to mention that it can be sensationalist, dishonest, or outright fabricated headlines to increase readership, clickbait, or such problems. So fake news is associated with a variety of problems, and all of these can actually mean different. In that sense, one more thing is in media, you might have seen Trump using fake news as calling mainstream media as fake news, right? So some people might even coin it as just some news something that you don't like, right? So the definition that I like a lot is a clear distinction between misinformation and disinformation. Misinformation is unintentional mistakes such as inaccurate photo captions, dates, statistics, and translations, or even satire, which is usually taken seriously. So this is without any intention of harm. Disinformation, on the other hand, is fabricated or deliberately manipulated audio-visual content, but I think we can include textual content as well, intentionally created for conspiracy theories and rumors. And there is also malinformation, which is deliberate publication of private information with the intent of harm, such as revenge porn or leaking someone's personal information. So in this talk, we will focus on misinformation to the large extent and disinformation to some extent, but not malinformation. So not everything is fake news, and misinformation, for example, is unintentional mistakes. And when people say fake news, I think when they're mostly talking about disinformation. So, and then why care about fake news? There was an MIT study which shows that fake news spreads 100 times further than the truth, and it actually spreads 6 times faster than the truth. So it can have larger impact on normal, regular, true news. And it is not a surprise that fake news has a socio-economic impact, whether it is about coronavirus or rumors resulting in lynching, or stock markets showing fluctuations due to false news. So how is the fake news detected today? It is done mostly through manual fact-checking, through fact-checking organizations such as Snopes, PolitiFact, Full Fact, FactCheck, and Faktisk, which is also a fact-checking organization within Norway, if you're not aware of it. So let me elaborate a bit more on how manual fact-checking works, and then that helps me to motivate the different problems associated with automated fact-checking. So typically what happens is fake news or false claims are generated within news media or social media, or they get circulated in social media, which are then consumed by end users. But on the other hand, there are these fact-checking organizations that I mentioned who are doing manual fact-checking by monitoring this news media. And there could be some automated tools in assisting them in these for monitoring. And then they manually analyze the claims which are made in this media. And so the first step in that is to identify fact-check-worthy claims. And once they have the fact-check-worthy claims, they need to retrieve relevant information for these claims, analyze the facts and evidences and sources, and then come up with a prediction that it is a false claim or true claim or whatever classification they have. And this typically takes, it's not a quick process, and this often involves several rounds of gathering evidence, analyzing, and coming up with a prediction, which could take anywhere from hours to days to come up with a prediction. So all the while, this can result in, as I mentioned, fake news can spread 100 times farther than true news, and so that can have a huge impact and damage, right? So time is of the essence. So in that sense, we need automated fact-checking techniques. So what we are going to focus on is these steps, which involve identifying fact-check-worthy claims and analyzing evidence, and retrieving the evidence and analyzing them for automated fact-checking. So I'll break the automated checking process into 3 steps: claim detection, evidence retrieval, which actually involves 2 sub-steps, which I will clarify about later, and finally, claim verification. I will talk about state-of-the-art techniques, deep neural networks used for these tasks, and if there is time left, we will also see some recent advances in multimodal fact-checking and open challenges in these areas. So let's start with claim detection. So claim detection, the main problem here is defined as given documents or transcripts of political debates with manually labeled sentences which say this sentence is a fact-check-worthy claim. There are typically 2 tasks. The first one is a classification task. The task is to classify these sentences into check-worthy factual sentence or unimportant factual sentence, so and non-factual sentence. So they distinguish between factual sentences and non-factual sentences, and within factual sentences, there is check-worthy and unimportant factual sentences. I will give an example of this in the coming slides. Another task which is less popular is given all these sentences, whether it is in political debates transcript or any document, we need to rank these sentences according to their checkworthiness importance. So actually, we will focus more on the first task in this talk, but the same data sets and methods can be used for ranking as well. So I will first mention which data sets are available for these tasks, and then we can look at some examples and some state-of-the-art methods and the method we have proposed and the results for that. So the first benchmark which is available, and to my best of my knowledge, this is the highest quality data set which is available out there for claim detection, is called Claim Buster, which includes, I think, over, I forget the exact number of political debates, which includes political debates, presidential debates actually, from 1960 to 2016. And it is a high quality data set because it is the fact check worthy claims are labeled manually by crowdsourced workers. So in terms of class distribution, you can see majority are non-factual sentences, but there is still a significant fraction of them, about 35% of them were factual sentences. Among them, there is check-worthy factual sentences and unimportant factual sentences. So in total, there are 23,000 sentences here. And the second data set is from a challenge, which is actually ongoing, by the way, if you want to take part in that. It's called Check.Dot as part of the CLAY tasks, which is also based on debates, but it is not just limited to presidential debates. It includes speeches, interviews, and town halls, 70 different debates, and so on. And the labeling in this data set is automatic, in the sense they automatically link the sentences to fact checks done in PolitiFact, which is a manual fact-checking organization. So there are a bunch of limitations of this. So this makes the labeling a bit more noisy. And actually, we did a bit of analysis on the data, and we found that there is significant number of sentences which are falsely classified as fact-check worthy claims, which makes it hard to train a classifier. In addition to that, if you were to look at it as a binary classification problem, the check-worthy factual sentences and non-factual sentences, there's a huge imbalance in the class, as you can see here in the class distribution. So that's something to keep in mind. So this is more suited for a ranking problem rather than a classification problem, I would say. So it makes it very difficult to train a classifier on this. So here are some examples of what are non-factual sentences. So for example, statements like, this is from a political presidential debate transcript. Statements like, I'm not simply going to do that. There's nothing to fact check here. And then there are sentences like, first of all, this is a nation of immigrants. So this is a factual sentence. It is possible to fact check it to see the fraction of immigrants as US population, but it is not important, at least from the context that it's a political presidential debate. On the other hand, there is another last sentence, which is about that this is the worst financial crisis since the Great Depression. This is a factual sentence and check-worthy, since the claim is, it tries to imply that the current situation is in a huge financial crisis. Right? So some first approaches were purely feature-based. For example, they made handcrafted features such as a bag of words, which is just representing the data in a vectorized form using TF-IDF weights I'm sorry, I'm going to probably end up using quite a bit of information retrieval jargon. If you're unfamiliar with that, I can have a chat with you after the talk. But it's just a way of representing textual data. Right? Other features include part of speech tags, named entity tags, dependency tags, and so on. And then feeding all these information to support vector machines. Right? This was the first approach to detect fact-check-worthy claims. And more sophisticated approach came in 2019 using deep neural networks, which includes bidirectional LSTM, which includes both word representations using word-to-vectors, and these features which were previously used for support vector machines were used along with the word vectors. Right. So each in this LSTM, the sentences are regarded as sequence of words, and each word is represented with both word vectors and combination of these some kind of representation of these linguistic tags, right? Like dependency tags and named entity tags and part of speech tags. Right? So we actually extended this idea to include context information. This is a joint work with a master's student at our university, Eirik Zakariasen. One thing we noticed was, especially in the political debates, it's important to also to consider the context. So if we consider sentences in isolation, that in itself does not give much information. So if we look at, let's say, previous sentences also include that in classifying the current sentence, that can provide much better context. So we also learn a representation for previous sentences that we call as the context representation and feed that to the bidirectional LSTM. So that's one improvement that we suggest. And another improvement is instead of word-to-vectors, we first simply wanted to try with more advanced transformer-based representation for these words. So we obtained BERT encodings for these words, and while keeping the same dependency or these kind of linguistic tags. So I don't want to go through the results quickly. Just a few research questions that we wanted to test in these experiments. The first thing was if these handcrafted linguistic features help. And there is a clear evidence to show when it, even with support vector machines, these features do help. If we consider along with, in addition to word representations, there is an improvement. And the other question we wanted to ask is context, which is the previous case sentence representations, if that helps. And it was a positive confirmation that indeed context helped. And finally, if these BERT embeddings that is an improvement over word-to-vec embeddings help, right? And that also, it was a conclusion that that also helps. But finally, actually, one thing that we noticed was, in a way, it is a negative result, is that BERT performed quite well, especially a variant of BERT called Roberta, even with simple text, raw text as the input, right? Even if you don't include these linguistic tags that I mentioned, like part of speech tags, named entity tags, and dependency tags, that in itself was performing already quite better. But the best performance was actually from the ensemble of all these approaches, as it is usually the case when it comes to different machine learning approaches. So that's claim detection. Next, I want to move on to evidence retrieval, which is the second stage in the automated fact-checking. And once we have a check-worthy claim in place, or we have selected check-worthy claims, let's say, identified them based on the techniques from the previous step, the next step is to retrieve relevant documents. And another sub-step in this retrieval part is actually retrieving the useful passages, or what we call as snippets, relevant snippets for fact-checking, right? Which what we say is constituting the evidence for checking whether the given claim is true or false. So typically the evidence is from web pages, or it could be from scientific literature, and as we will see some examples in the coming slides, it can be also from knowledge bases or table data, or it could even be any databases, right? So it can be heterogeneous data sources. But unfortunately, the research for document retrieval for fact-checking is not as significant as other steps in automated fact-checking. Sorry. So it is mostly done using simple information retrieval methods such as TF-IDF and BM25 models. Or in practice, when people are deploying demos and using it in real settings, they just rely on search engines to retrieve the relevant documents. So in the second subphase of this retrieval part, in order to retrieve useful passages, again, people use information retrieval techniques or similarity-based techniques, like just cosine similarity, again, based on TF-IDF or BM25 models. But there are some methods which use it as a classification task, or using advanced models like BERT for ranking or re-ranking passages within these documents. So in my opinion, this is a significantly under-researched problem, and there are plenty of open problems here to be addressed. So in order to show the latest advances in the retrieval part, I want to introduce the task, which is called SciFact task or SciFact challenge, which is actually also ongoing if you're interested. It is classifying scientific claims as supported or refuted based on scientific literature. So the data is quite reliable and high quality in the sense that because it is curated manually. What they did was ask the annotators to, they presented abstracts from the scientific articles and then asked them to come up with claims. So for example, here there's a claim that cardiac injury is common in critical cases of COVID-19. And in order to support that claim, they need a snippet from the abstract of a scientific paper which shows that COVID-19 infection is associated with higher mean troponin, which is a protein which is found in the cardiac muscle, right? And with the statistical significance and so on, right? So, so they provide this kind of labeled data, and the task is to both retrieve these relevant sentences, what they call as rationale sentences for this claim, and coming up with a stance, which is basically the task of classifying whether the evidence supports the claim or disproves the claim, right? Or refutes the claim, right? So I will discuss a couple of solutions for this task, and then we can see, like, especially what they do for retrieval part, right? So the first solution is called a paragraph joint model. The reference, the paper which proposes the solution is at the bottom of the slide, if you're interested. But the interesting part is they just use a simple information retrieval model for the first step of retrieving the abstracts, relevant abstracts for the claim, right? And in the second step, they propose a classifier which is with a task of, it's a multitask classifier, which jointly classifies the rational sentences and the stance, right? The rational sentences is this evidence sentences I mentioned, and stance is whether these evidence sentences are supporting the claim or disproving the claim. The exact architecture is not important, but what they do is use BERT encoder important, but what they do is use BERT encoder along with self-attention to represent the claim text and the rationale sentences, and then use a multi-layer perceptron to classify rationale sentences, and another self-attention, it's a multitask classifier, right? So it jointly classifies both rationale sentences using a multi-layer perceptron and another self-attention based or graph attention network based classifier to classify stands as well. And I also want to mention another solution which is actually leading the leaderboard in this challenge is called T5 Serini, which is based on the recent T5 transformer model, which is which was also trained for a multitask setting where they formulate different text classification tasks as a text-to-text model, which makes the model very diverse and multi-purpose. So the nice thing about this approach is that they show how we can use T5 for all three stages about, or all three parts in the task for both retrieving re-ranking the abstracts or rationale sentences, and also for later on to classify the rationale sentences and do a stance detection. So here's an overview diagram. It shows in the first stage they do what we call a pseudo retrieval, relevance retrieval using again a simple IR information retrieval model BM25. They shortlist bunch of abstracts from the scientific papers, and then use T5 model to re-rank these for the claim. And then again, these re-ranked abstracts are at the sentence level are classified as rationale sentences or not, and then which is then finally used for, again, stance detection. So I quickly want to show how the leaderboard looks. As you can see, among the top five solutions, 4 of them are this word T5 Serini and paragraph joint model. So one thing I wanted to highlight here was both of them start off with simple IR-based retrieval, right? But in my opinion, this is still retrieval for fact-checking is still under research. They just assume that information retrieval techniques are the best solution here. Retrieving for fact-checking, which should include both supporting and refuting evidence, is, in my opinion, significantly different from just using simple similarity-based information retrieval techniques. So one more thing I quickly want to mention, because I mentioned about using heterogeneous kind of data as well, right? So there is another work which is using Wikipedia tables as evidence for fact-checking, right? So in this paper, which was published in ICLR 2020, they also release a relatively large-scale human annotated table-based facts. Based on 16,000 Wikipedia tables, they asked annotators to come up with natural language statements. So given a table like this, whether statements like John J. McFall is unopposed during the re-election, if there was any opposing competing candidate for this candidate or not, right? So this is not a simple task, right? So given a table, coming up with entailed or like supported and refuted statements is a pretty involving crowdsourcing task. And then they also go on to propose 2 different solutions for this as a strong baseline. So the first one is a programmatic solution where, given a claim, they convert it to a programmatic set of instructions, which is then applied on the tables to compute, if it is related to counting something or comparing something. They have, it's more like a rule-based solution. It's a rule-based and template-based solution for example, for a claim like there are more Democrats than Republicans in the election, then they need to count the number of Democrats and Republicans by filtering them, and then counting, and then do the greater comparison. Right? So this is automated programmatic evaluation of this. And they also propose a text-based evaluation where they linearize the tables. So if there is a table about some games, so if row 1 is about a game on February 3rd, 2009, which had opponent Florida and score so and so, they just linearized whatever is the content of the tables and use that as just to feed it to a BERT classifier to come up with this entailed or refuted prediction for the claim. So again, I quickly want to show the results. Here, the BERT-based and the automated programming solution, which is LPA, are similar in performance. But the main thing I want to highlight here is that, they are still significantly far behind the human performance. Right? So there is a lot of headroom to catch up. Right? Okay, so that brings me to the last part of the automated fact checking, or the last step in the automated fact checking, which is claim verification. So actually, I want to have a quick quiz here. Which of these claims do you guys think is false? Let me launch a poll while. Yeah. So the main reason I want to conduct this poll is to see how many of you can spot these spot the false claims here by just looking at the textual surface form of the claims, right? So I'll give like I don't know, 30 seconds, and then we can continue. Yeah, okay. I think I'll end the poll here and share the results. So there is no consensus, right? Or like there is no single outstanding answer that you could think of. The actually correct answer is the B, which is US has the highest rate of deaths from gun violence in the world. That's actually false. It's not the US. Even though from recent news, you might think that. But the first one is actually surprisingly true. There was a recent comparison to show that getting a blood clot is almost the same as being killed by a cow. So that's a statistical analysis, right? So I'm sharing the results, yeah. The main point I wanted to make here is that it is impossible to guess whether a claim is true or false just by looking at the statement, right? So we need external evidence to classify whether a claim is true or false. So indeed, it has been shown that in the literature, in addition to claim text, including an external evidence, significantly improves the performance of automated fact-checking. The reason why I mentioned this, the first, is that the early solutions for fact-checking were just looking at the textual content of the claim text, and based on the stylistic nature and the vocabulary in the claim text, they were classifying this as true or false, which is completely difficult. Let me just quickly stop sharing the poll. Yeah. So that. Yeah, okay. So instead, the problem we are focusing on here is given a claim, and along with evidence from online sources or any other sources which are relevant. Again, here we assume that the retrieval part is taken care of, which retrieves the evidence, which is from the previous step, which most people use simple IR techniques or search engines for that. Right? So using these sources to classify whether the textual claim is true or false. Right? And as a side effect of this, we can use these retrieved sentences or sources as evidence. Right? So this in practice is a bit of a problematic, especially if you just focus on the text, it may not provide, again, enough context to classify something as true or false. So here's a claim. I guess you can make a guess who made this claim, which is saying that the Dems and their committees are going nuts. The Republicans never did this to President Obama. And the evidence from the web says that while Republicans didn't launch investigations into Obama, there were several investigations into Obama's administration. So this is basically based on this evidence. The claim is false, but it's not that easy to find out, right? So especially if you think from the machine's perspective, it is not that easy. So just by feeding these into neural networks and hoping that it works is it's a bit of a problematic. So and then people came up with ideas like attention or cross attention or word level attention by applying which words in the evidence text are important to classify this claim as false, right? Maybe, so if you look at the word level attention, it's looking at things like Republicans, President Obama, and it's a bit of a hit and miss. Whether relevant words are captured or not, it's hard to say. So there are still other clues that we could have used this to classify much better if we knew more information. For example, the kind of language that is used in the claims, like going nuts and the Dems, this Trump uses such vocabulary in making certain types of claims, right? And then there are also other more, professional, probably somebody with a professional journalism background would have written is about looking into congressional investigations of prompted, significant, and so on, which could be missed in the simple text word level attention. So the challenge here is that the text word level attention misses the important context information. So as I mentioned, if we also know additional metadata about these claims, like who made the claim, what we call as author, and what it is about, the subject, which is, let's say this is about Congress or congressional investigations, we could have captured a better vocabulary. So that's our hypothesis, right? And then finally, the fact that it's coming from WashingtonPost.com, we can also expect certain kind of vocabulary or certain standards in the style of writing, which could be relevant for classifying this as true or false. So our hypothesis is that we call these as different aspects in claims. So if we have access to this information, we can do better classification of claims. And then another hypothesis we make is that in addition to word level attention, if we also do sentence level attention, we can capture the important sentences. Within the evidence snippet, there could be more important sentences compared to all other sentences, right? So based on these two hypotheses, we propose what we call as latent aspect attention model, which is a hierarchical attention model, which was a joint work with a PhD student here at the University of Stavanger, where we come up with parallel models for subject, author, and domain, which includes guided attention both at the word level as well as at the sentence level. I don't want to go into the details of this. So at a very high level, what we do here is that for each of these aspects, suppose if we know that the speaker or the author of the claim is Trump, we have a vector for Trump in this vector, which is guiding which words and sentences to focus on when classifying whether the given claim is true or false based on the evidence. Right? And another nice thing about these aspect vectors is, in addition to improving the classification, we can use that as in a way to extract evidence or interpret the models, what the model was looking at when it came up with the classification. This is what we call as latent aspect guided attention. I'm actually running a bit low on time, but I don't want to go in details of experiments. We used data sets from manually fact-checked data sources such as PolitiFact and Snopes, and we show that these attention, especially aspect-based attention and hierarchical attention, helps in improving the accuracy. And another thing I wanted to quickly show is this aspect-based attention captures these vocabulary which we otherwise observed was not captured by only word-level attention. So, for example, the good example is related to the subject taxes. This claim is about the US is the most highly taxed nation in the world. Because it is about the subject taxes, it is also focusing on words like corporate tax, income taxes, and so on. And in addition to word-level attention, what you see in the left-hand side is this color gradient indicates which of these sentences are given higher attention weights compared to other sentences. So another nice thing about these attention vectors I mentioned is we can visualize different aspects of the claims, such as who made the claim. If we look at the claims made by Trump and Ted Cruz, by doing dimensionality reduction and scatter plotting them in 2 dimensions, we can see that Donald Trump and Ted Cruz are much closer compared to Donald Trump and Barack Obama. And we could observe a similar behavior with the topics or subjects as well, like climate change and healthcare is much closer than federal law and civil rights. And when it comes to domain, we could also observe a nice clustering of mainstream media like BBC and New York Times compared to these alt-right websites such as Breitbart and so on. I quickly want to mention about another follow-up work that we did, which uses user comments in social media forums such as Reddit to improve the fake news detection or fact-checking, right? So given a claim text along with the article, we look at the comments which are in the subreddit. Sometimes, false claims made in the articles are disproved by the user comments. And the user comments actually provide evidence, which can be useful. It was a nice exercise to see if these user comments actually help in improving the performance of claim classification. And again, I don't want to go into the details of the results here, but we show that combining the representations of user comments and the article improves the performance. We also have a demo for, based on these models. I don't think I have time to show that, but if there are not many questions in the end, I will show the demo quickly. Yeah. So before finishing, I want to show advances in this multimodal fact checking, which is about fact checking in images. So this the first work that I'm aware of in this area was something called event adversarial neural networks for multimodal fake news detection, which includes both textual content and the images. And they use an adversarial neural network to learn the features, both textual features and the visual features from the images, and use discriminators. It's more like a GAN style of model where there's feature extractor and discriminator, which is doing both fake news detection and also extracting what they call as event agnostic features, which can be used for downstream tasks. Actually, I have another quiz here, to classify which of these images and corresponding claims are true and false. And actually, there is a new term for this kind of analysis. It's called foxtography, which is about detecting false images used for, with malicious intent or with the intent of harm. Okay. I think that I had to exit the full screen. Maybe I'll skip this. So basically, it's a combination of images and text. So this is a true image making a true claim, along with a true claim that this is a Tesla vehicle showing in space, right? And this is Putin pulling tie of Barack Obama. That's a fake image making a false claim. And then finally, this is a true image, which is actually holding a palm-sized rabbit. It is a true image, but it's a stuffed toy. It's making a false claim because it's a palm-sized rabbit. Right? So the foxtography is the problem of this, given a combination of images and textual claims, classifying whether it is a true claim and true image and so on. So there are some data sets available collected from Snopes and Reuters. If you are interested, there is a reference for that. They also provide a nice baseline for this. So they do both analysis in terms of whether image was manipulated based on the visual features. And then they also do reverse image search to find out, if using Google APIs, if this image appeared in a good website or bad website, and whether the content of the website supports the claim or not. Right? So that's pretty much it. What I wanted to show. But there are a bunch of more works in this direction, which I will provide the references to in the end if you're interested. And to summarize, fake news is a loaded term, and it is important to distinguish between misinformation and disinformation when we are trying to automate this process. Right? We cannot, if anybody is saying that we can do perfect fake news detection, or it is, I mean, they're also making false claims, right? We need to really carefully think about what is the exact task they're trying to solve. And automated fact-checking involves claim detection, evidence retrieval, and claim verification. And we saw several deep neural network-based solutions for these tasks, right? And basically, there is some promising results based on these deep neural networks, but still there is headroom to be caught up with human-level performance. And finally, multimodal fact-checking does exist, but more work and data is needed here. So quickly to wrap up some open challenges here, deep learning models, while they are promising, they do not yet meet the human-level performance. This is mainly because it is hard to obtain large-scale, high-quality human manually labeled data, because it's quite expensive and time-consuming. So we need weak supervision, distant supervision, or unsupervised techniques, or even online learning or reinforcement learning techniques that could be improve the performance even without high quality labeled data. So in this SFI, in our work package, we will address some of these problems. And claim detection is a hard problem because actually fact checkers themselves don't have a consensus on the definition of what is a checkworthy claim. And it's also hard to come up with labeled data for that, and also train a classifier because there is no agreed upon definition. And as I mentioned, retrieval for fact-checking is under-researched. There are several open problems here, especially retrieving both supporting and refuting, different angles of articles for a given claim, not just relying on simple IR-based models. And claim verification, while the current solutions do work when claims are very crisp, and if each claim contains a single claim, as soon as it contains compound claims, like multiple claims in the same sentence, they fail. And it is also a challenge to include heterogeneous data sources, as I mentioned. I mean, there's some works on just looking at news, just looking at scientific literature or tables, but combining all these forms of evidence is still an open challenge. And I haven't seen much work on temporal aspects of the claims as well. So quickly want to give a shout out to ECIR tutorial, from where I also borrowed some of the slides and the content. And with that, I thank you and open for questions and leave you with the references.